Confused with what are units and measurements? Let us understand everything of this chapter through a story. Once you went to a market and you heard different fruit sellers saying 1 kg apples are 200 and another vendor says 1.0 kg apples are for 200 and another vendor says 1.00 kg apples are for 200 rupees. Well, essentially all of them mean the same thing, but what does it imply? Well, we have three different readings here, each saying 1 kg, 1.1 kg and 1.00 kg. But the significant figures in all of the three readings are completely different. The extra zeros tell us how accurately the measurement was made. So these significant figures help us in accuracy of our readings. There are certain rules of significant figures, such as all the non-zero digits are significant. So in 3, 4, 5, 7, number of significant figures are 4. The zeros between non-zero digits are significant. So if I am writing 20,005, it has 5 significant figures. Leading zeros are not significant. That is 0.0045 has only 2 significant figures. And trailing zeros are not significant, which is when we write 345 meters or 34,500 centimeters, both have 3 significant figures. Trailing zeros after a decimal point are significant. So in 0.6730, it has 4 significant figures. And the number of significant figures post mathematical operations should be either the least number of significant figures or the lowest decimal value significant figures. So if we are adding 0.123 plus 0.0450, the answer is 0.163, which is 3 significant figures, which is also the least number of significant figures. Significant figures prevent us from claiming more accuracy than our instruments provide. So a vendor can never say that 1.00000 kgs is 200 rupees. Let us see what is accuracy and precision. So in the kingdom, there are 4 warriors, Arjun, Yudhishthir, Nakul and Bhim, practicing archery. The Gurudev said to point their arrows and start marking the bullseye and shoot the arrow. Once the shooting is done, this is what the Gurudev had recommended. Arjun was accurate and precise because all his arrows were in the bullseye and every arrow that he hit was in the bullseye. Yudhishthir was precise but not accurate, as it didn't hit the bullseye but all the arrows were similarly misplaced. Nakul was accurate but not precise because there were some arrows that hit the bullseye but not all of them were consistent. And Bhim was neither precise nor accurate. So this is what the Gurudev explained, that accuracy is close to the true value, in this case the bullseye, and precision is repeated measurements are closer to each other. Let us understand different errors from the same story. So the king wanted to build a rope for the prince and called 3 tailors to help measure the height of the prince to make the new rope. The 3 tailors, Shantanu, Satyavati and Ganga, had the following readings for the rope and wondered why each reading was different. Well, the minister then mentioned that every measurement has some error in it and no measurement is perfect. The different errors are random errors which happen because of human errors such as different eye position, posture, reading mistakes, etc. Systematic errors are errors where the measuring device itself is faulty. In least count errors, least count is the smallest value that an instrument can measure. So measuring something below the least count of the instrument can cause least count error. Absolute error is how far is the measurement from the true value, and relative error is the absolute error compared to the real value, and percentage error is relative error expressed in the form of a percentage. These were the different kinds of errors that we saw. In the same kingdom, once a scientist claimed that he can tell if a formula is correct or not. Then Mr. Newton reached the scientist and said, "Can you confirm that my formula for an apple falling from a tree that travels a distance of s, which is given by ut plus half at square, is correct or not?" Then the scientist explained, "I will surely do it." And he described that every formula can be given 3 tags: length represented by L, mass represented by M, and time represented by T. So for every formula to be correct, both sides of the equation from the dimension point of view should be equal. So expressing distance, which is length, time, which is T, u, which is velocity given by distance by time as L by T, and acceleration velocity by time given by L by t square. If we multiply and substitute this in the formula, we get L is equal to L by t into t for u into t plus half, which is a constant and has no dimension, into acceleration, which is L by t square into t square. This, after cancelling the t's, gives us L is equal to L plus L. Since we have L's on both the sides, the LHS is equal to RHS, hence the formula is consistent. This is how the dimensional analysis helps us in understanding if a formula is correct, or derive a formula if we know what the equation depends upon. Hope this has helped you understand this chapter better. Like this video and comment below if you have any questions, and subscribe to this channel for more quick concepts for 11th class physics.